Now let's take a quick look at substitution method. Let's say we're solving these two equations using substitution method. Okay, by substitution, from the name, it implies that we're going to be replacing one thing by the other thing to get the value till we get the value that we need. Okay, all right. So now we have equation 1 given as 2x plus y equals to 12, and we have equation 2 given as minus 3x minus 5y equals to minus 11. That's equation 2. Okay, so now from what you have there, you can conveniently, of course, looking at this, the procedure says the first thing we do is we make one of the variable and one of the equation the subject of the formula. So meaning we can choose any equation. Of course, in any equation, we can also choose any variable first. For instance, I can decide to choose y here to make the subject of the formula. Of course, I can decide to also choose x, okay? Or I can decide to come to equation 2 and choose the y there to make the subject of the formula. Or I choose x to make the subject of the formula. So in any case, by observation, you just choose what is suitable or the one you are more inclined to. But based on what we have here, I decided to choose equation 1 and I choose y to make the subject of the formula. The reason being that it's more direct, okay? Whatever you do in mathematics, the purpose, end result is that is expected is a simplification, okay? So if what you are doing is not bringing in any form of simplification, you know that there is a problem, okay? So, or you might just be creating more problem than the solution you are trying to solve. Eventually, irrespective of what you choose, you will still get your answer, provided you are applying acceptable procedure, okay? So meanwhile, what I'm trying to say in essence is that I choose y here in equation 1 because it's more convenient, okay? Making y the subject of the formula, okay? So now, that means we have another equation which we tag equation 3. I believe you can see that. That's our equation 3. The next thing we are doing now is to put the new equation into the equation that has not been touched at all. Now, look at what the statement says. It says that substitute that expression into the other equation. Substitute that expression into the other equation, meaning the equation that has not been touched at all. If you look at it very well, this equation here was formed from this. So the one that we have not touched at all is this equation. So we substitute the expression into that equation. So that's why we say we put y into the equation 2. Okay, so we replace y in equation 2. That's why we say we replace y in equation 2. In some cases, we say we substitute y equals to 12 minus 2x into equation 2. So what that one means is that this y here, wherever you now have y in the other equation, don't forget the reason why we pick the second equation is because we have used the first equation. So any equation you have used, you don't use it again until you have found your answer. You have to use something else because if you use that same equation, everything will become 0, which will not give us our answer. Okay, so now put y equals to 12 minus 2x in equation 2. So if we do that, of course, this is our equation 2, and if we replace y here by the expression here, of course, that means we have a 5 minus 5 into 12 minus 2x, of course, which we can sort out by doing the multiplication. We know that minus 5 we multiply 12, and also minus 5 we multiply minus 2x. Okay, so that means that will give us minus 3x minus 60 plus 10x equals to minus 11, which you can then sort out by, of course, getting the next value out after you have collected your like terms. Okay, so that means we have 7x equals to 49, and then we can divide both sides by 7, which will then give us x equals to 7. Okay, so from there, of course, we can conveniently say that we have solved the question for x. Now, after finding x, the next thing we have to do is to find our y. What do? You can put your x equals to 7 inside any equation at this point, because you have gotten the value of one of the variables. So it will be valid, especially if you have not made any mistake in your solving. It will be valid. So the next thing is, of course, we are going to put it. Now, where should we put it? That's the next question. Where then should we put it? We substitute the solution into the other equation to determine the value of the other variable. The easiest option for us to put our value of x is equation 3. You can put it in equation 1, you can put it in equation 2. Either of them is fine. But because this is more direct, y has already been made the subject of the formula. So you can easily just slot in the value, of course, in place of x. Okay, so that means we say we put in place of x here, we put 7. So if we put 7, that will give us our final answer, y equals to -2. So we have our two answers. That's x equals to 7 and y equals to -2. That's the answer. Okay, so now let's take a look at the second question. We have the second question. Okay, let's take a look at the second question. We have x plus 2y equals to 5 and x plus 3y equals to 8. Of course, that's our equation 1, and we have our equation 2 as stated. And we have our equation 2 as stated. Okay, so now from equation 1, as usual, of course, we understand the implication of equation 1 and easily make x the subject of the formula. So if you're making x the subject of the formula, you agree with me that we have x equals to 5 minus 2y. That's from equation 1. Okay, so if you have that, we can of course say that is our equation 3. So from there, we can put x equals to 5 minus 2y into equation 2. So we know this is our equation 2. So what we are saying is that in place of this x here, we'll replace it with this guy here, of course, which is what this statement is saying. Of course, from there, we have our equation 2 stated that x plus 3y equals to 8. So from there, we have 5 minus 2y plus 3y equals to 8. Okay, so it's in place of this x here that we have put this. Okay, that's why we have this. Okay, so that means, of course, we just collect like terms and then simplify further, in which case we have our y to be equals to 3. So from this, if you decide to substitute y equals to 3 into equation 3, like I said, you can use any equation at this point. Okay, so that means we have x equals to 5 minus 2 into 3 instead of y there. Okay, so which if you solve further, you have x equals to -1, which is that as far as that is concerned. Now let's take a look at the third equation. Now this is a little different in that our unknown is in form of fraction. You look at it, you have 3 over x here, you have 3 over x, and you have 5 over y. Okay, x and y is also denominator in this case too. So how do we go about it? Of course, it's something that you can solve directly if you understand the way it flows. But for the sake of convenience, it is good to rewrite it. Now, in this case, we make use of substitution. So I can call this one double substitution method. Okay, what I mean by double substitution method is we are substituting, replacing the value that we're looking for with another value. After finding the other value, then we now find the value that we're actually looking for. Okay, the statement will make more sense to you as we progress. So you will agree with me that the equation here is the same thing as this. Okay, if you agree with me, now let's take a look at the second equation too. You agree with me that this is the same thing as this. Okay, because 9 times 1 over x will still give you. So we're just rewriting it to bring out the similarity in the two equations. Now I target equation star and equation star star because they are not our main equation. So we do that also in mathematics. It's just a way not to make everything look too cumbersome. Yes, with plenty equation numbers. There are cases where it's unavoidable. If you have to have up to 10 equations, tag. There's no problem with that. But when it's avoidable, like this case, it's not our main equation. I use star, and I'm using star star in this second equation. So now from what we have here, we can then simply say, let 1 over x be equals to a, and 1 over y be equals to b. Okay? 1 over x, of course, equals to a, and 1 over y equals b. So if we are doing that, that means all the equation will become from equation star. We can say we are replacing this with A. We are replacing this with B. So that will give us equation 1. Okay. So if we do the same for equation 2, what do we have? We have 9a plus 4b equals to 5. That's equation 2. So now we solve the equation 1 and 2 simultaneously. Okay, let's say we want to use the elimination method. And if we decide to eliminate a, if we're eliminating a, now the issue with that is 2 ways you can do it. Is either we use the flipping, meaning that the 3 here, we multiply everything in equation 2, and the 9 here, we multiply everything in equation 1. Or, since our objective is to make the coefficient of a equal, if you look at it very well, if you multiply this by 3, it will make it equal like that. Is that not? But you know the rule is anything you multiply to one side of an equation, you must do to the other side of the equation. So we can multiply everything here by 3. Of course, this place we multiply everything by 1, which is what we have here. Of course, if you multiply through by 3, it will give you that. And if you multiply the second equation by 1, it will give you that as well. And from there, of course, because they have the same sign, you can subtract, okay? What we are eliminating have the same sign. So that means we say minus, of course, this will give you 0, and the minus coming here, that's minus times plus, will give you minus, that's 15b minus 4b, that's going to be 11b. And 12 minus 5 here will give you 7. Okay, so from what you have there, you can conveniently say 11b equals to 7, which if you divide both sides by 11, you have b equals to 7 over 11. So after finding our value of b, we can then go ahead and sort out the value of a, of course, by putting our b value into any of the equation. So let's substitute b equals to 7 over 11 in equation 1. So let's choose equation 1. You can choose any one, like I said. When it comes to elimination method, once you have found one, and put your value into any of the equation. Okay, so now for equation 1, it gives us this, and if you evaluate further, of course, 5 times 7 will give you 35. Okay, which you're going to have this, and from there we multiply through by 11 to just eliminate fraction from the equation, which is going to give us this. And from there we can conveniently say that 33a, can conveniently say that 33a equals to, so which is going to give us, that's 3a, 3 in 33, 11, that's going to be 3 over 11. So that's our answer there. So then we can recall, because we are recalling from here. So we recall that 1 over x equals to a and 1 over y equals to b. So if you do that, 1 over x equals to 3 over 11 according to what we have here, and 1 over y equals to 7 over 11. But let's evaluate our value of x first. So from there, you can see x equals to 11 over 3. X is therefore equals to 3 over 2 over 3. Now, for the other case, 1 over y is going to be equal to 7 over 11. In which case, we can then cross multiply to get our value of y after dividing both sides by 7. Okay, so our x value equals to 3 over 2 over 3. Now y value equals to 1 over 4 over 7. So let's take a look at a similar equation to the one we just finished. The only difference between this and the other one is this. In this case, our unknown fraction does not have a coefficient greater than 1. Yes, that's the only difference. So it's still the same mode. We'll write the equation, target star and star star. So we can then do our replacement. 1 over x equals to a, 1 over y equals to b. So from equation star, you can correctly simply replace 1 over x by a and 1 over y by b. And if you do that, you have the value of our first equation, a plus b, is going to be equation 1. And if you do the same for equation star star, you have b minus a equals to 1, and which you can rewrite. The only reason why I'm rewriting it is so that it will have the same form as this for ease of evaluation. Okay, so now from what you have there, if you look at it very well, you discover that you can conveniently, because if we say we want to eliminate a from here and we are eliminating a too from here, you can see they have different sign. This is plus and this is minus, which you can just easily eliminate a by adding equation 1 to equation 2, which if we do, we have that, and that will give us what we need. Of course, b plus b will give us 2b, and 5 plus 1 will give us 6. And from there, you can say 2b over 2 equals to 6 over 2, which we say b equals to 3. Substitute b equals to 3 in equation 1. What's our equation 1? A plus b equals to 5. Okay, so we can just simply put b equals to 3 there, and then from there we have our a equals to 2. So the two values has been sorted, a equals to 2, b equals to 3. But that's not our final answer, and that's the more reason we have to be very careful. If you stop there, you will miss out on your final answer. That's what your solution is supposed to be. Okay, we are recalling again. We are recalling our friend here from here. We are recalling. Okay, So since it's x and y that we're looking for, we have only found a and b, which we use as substitution to substitute for ease of operation for us to see our simultaneous equation in the light that it is. Meanwhile, you are not limited to use a and b. You can decide to use m and n. What matters is you use a different letter from what has been used already so that you don't get it mixed up and so that you won't confuse your examiner. Okay, so now from what you have here, 1 over x equals to 2 and 1, if you cross multiply, will be equals to 2x. That's if you cross multiply this over 1, do your cross multiplication. Okay, so you have 2 equals to 1 over x, and that's 2x equals to 1. And if you divide both sides by 2, you have x equals to 1 over 2, which you can still, of course, solve the second equation further. We have 1 over y equals to b. So 1 over y, since our b is 3. So 1 over y is 3. You cross multiply, you have 1 equals to 3y. And 1, then you can say y equals to 1.